Good day everyone, my name is Robbie Pedrica. I'm a network security consultant from Cape Town, South Africa. I recently did a video on the basic setup of a FortiGate. It was a fairly simplified view of the setup, and today in this video I'm going to take the opportunity to expand on some of the configuration items that we discussed in the first video. That will include items such as naming conventions, in-depth dives into security profiles, policies, FortiView and logging, as well as a discussion on various interface types and load balancing methods. The first item we're dealing with today is naming conventions, which are extremely important for readability and maintainability, especially when you have multiple engineers working on the same systems. It's important to document your naming conventions so that engineers can refer to these when working on devices. I tend to only use lowercase. It's then unimportant whether an object supports both lower and uppercase. I also don't use any special characters, including spaces. There's any number of naming conventions that you can use for objects within firewalls and network devices. I'm going to take you through a few of those that I might use. We'll log into our testing workstation, go to Policies and Objects, and Addresses. You might recall that we had a local LAN of 10.10.10.0 with a subnet mask of 24. As we didn't have an object for it, we didn't use it within our policies, so we're going to create one now. As I mentioned, there are a variety of naming conventions that you can use, but I'm going to use the following. The name of the network followed by /net, indicating that this is a network. You could also, for example, use network name and the actual network specification. In our case, our address is 10.10.10.0 with a Class C subnet, and I'm going to bind it to our local LAN port. We'll accept this change. We can now use this address object within a policy. If we go to our Ipv4 Policies section, we can now change the all identifier in our policies as the source to our new object. We'll edit the entry, select our object, and apply the change. We'll do this for other policies. I want to add an additional policy on here as a fallback in case our web and email policies do not trigger. So I'll create new, give the policy a name. We'll select our incoming and outgoing interfaces, and for our source we can now select our local network address object. Our destination will be all, our services will be all, because this will be matching everything other than our web and email services in the first two policies. Make sure we have NAT enabled, log all sessions, enable the policy, and accept those changes. You might recall that when we did our network interface configuration that we used the alias field within each interface to specify a name for the interface. This is another example of object naming convention. This is carried throughout the FortiGate for all objects. Another example might be authentication objects. For example, if we were creating an LDAP server or a radius server. We're now going to move on to some more in-depth configuration options within our security profiles, and we'll start off with web filter profile. As you might recall, our unit is currently unlicensed and therefore FortiGate services will not work, but I will take you through some of the options that are available. Broadly, FortiGate web filters based on categories have upper level categories as well as sub-lower categories. These are the list of upper level categories, which we can then open to see our sub and lower level categories. You can simply click anywhere in this tree and set a value for the action for this category. Those actions include allowing but not logging a category, blocking the category, allowing and logging data about the category, presenting a warning, or requiring some form of authentication. I can, for example, choose to set monitoring at the top level or change individual items. Another item that's quite important is safe search, and this allows the FortiGate to advise the search engine that you're using to only return search results that are deemed to be safe. YouTube can also be similarly restricted, and there are two levels, moderate and strict. We can choose to log search keywords in search engines. The next session we'll deal with is the URL filter. The static URL filter allows the administrator to configure URLs in the UI that will be used to block or allow access to websites. You can enable the URL filter and then create entries. For example, I might add a website that I would want to block for certain reasons. A variety of matching types are included, including regular expressions, and as per web filter categories, there are a number of actions that can be taken. That's it for our web filter for now. We'll accept these changes. We'll now move on to application control. In the first video, we made some selection changes in the categories for our application control. We can also make adjustments to these categories as per the web filter by using application or filter overrides. Application overrides are typically used when you need to make changes for some specific applications. In this case, I'm going to choose name as a filter criteria for finding Skype. I can now select the specific application that I'd like to make changes to. Use the selected signature. Once it's in my override list, I can choose what action to take for this particular application. An example would be if social media was blocked and I wanted to allow Facebook. I'll add that quickly. I'm going to use the filter type name, search for Facebook, make the selection, use the signature, and then allow this particular application signature. Whereas in application overrides you are choosing specific application signatures to make changes to, in filter overrides you're basically using a filter specification to choose groups of applications. An example is I'm going to choose the application group from Microsoft. I'll use this filter and you'll notice that all application signatures relating to the filter search specification I used are included. I'll apply these changes now. The next section we'll move on to is Intrusion Prevention. Intrusion Prevention, or IPS, provides a very powerful system in blocking certain types of attacks, both from a server point of view and a client point of view. You'll notice that there are a number of predefined profiles included by default. For example, we've got a profile to protect email servers, web servers, as well as protect clients. We'll create our own signature profile set to show you how this process works. I'll call it protect SSL. We can choose to block malicious URLs as part of the profile. This makes use of FortiGate services. As with application overrides, we can either choose individual signatures or groups of signatures based on a filter. That's what I'm going to use in this example. My filter specification is going to go according to protocol, and I'm going to choose the SSL protocol. All applications that include a protocol of type SSL will now be listed. I can then use this filter and my selection will now be included in the main profile. There are a number of additional rate-based signatures that can also be applied within an IPS profile. These make use of a threshold to determine when the sensor has been exceeded and a block should take place. I'll take one example here using Microsoft RDP. Oops. We can see if we hover over the signature or the rate-based signature, we can see some details about it. And the default here is that a block will occur if it has more than 200 requests in a 10-second period. You can of course adjust these thresholds per your requirements. There are also certain actions that can be taken should the threshold be exceeded. I'm going to accept these changes. This profile can now be included in a firewall policy. The next section we'll look at are some advanced controls in the policy section. We'll go to Policy and Objects, Ipv4 Policy, and you'll recall that we have our three policies to allow web traffic, email traffic, and fallback traffic. The first advanced function we'll look at here is the ability to select columns according to your requirements. For example, we might want to see individual security profiles, and we can select the specific types of profiles we'd like to see in the policy list. We might want to see whether IPS is enabled, how many packets have passed this policy, and what the status of this policy is. I'm going to choose hit count. You'll notice that this new column gets tacked on at the end of the policy columns. From the column specifiers, we can also choose filters to limit the view of what we see in the policy list. Predefined values can be included. As well, you might search for specific values. I'll search based on WAN 1. In this case, all our policies are selected. However, the implicit deny rule is not shown. We can click on the filter icon and remove the filter at any point in time. If you don't see certain information in the policy viewer, take a look and make sure that you don't have filter set that might limit the data that you are seeing. Additional controls that we have in the policy viewer are accessed via a right-click sensitive menu. We can, for example, enable or disable policies, add filters, copy the rule as well as paste it, insert empty policies above or below, insert a sequence grouping, show logs or FortiView views for this policy. We can edit the policy, edit it in the CLI or delete it. I'm going to create a sequence grouping. We'll add a name for the sequence. And you'll notice that there are now subsections within the policy viewer. I can add an additional sequence grouping. And a new section is created. This is an extremely useful tool in organizing your policies into logical subsections. The last item we'll look at in the Ipv4 policy section is the policy lookup tool, and this allows you to check whether a policy will match based on certain search criteria. For example, I can set my source interface to LAN, choose a protocol for my traffic. I can specify a source address. Going to add one on the local LAN. This can be fictitious, of course. I'm not going to add a source port as this is generally random. I'll add a destination IP address as well as a port, so this should trigger on HTTP traffic. Let's do a search. You can see that the policy lookup feature has identified the policy that will trigger based on my search criteria. Just as there are filter and column selections within the policy viewer, so there are in FortiView as well. If I choose, for example, the sources view, I can adjust columns and I can create filters as well. For example, I can filter on a specific IP address. If the FortiGate has recently seen an IP address, it will list it here as a predefined option that you can select without having to type in a specific value. We also have the ability to do filters within the log and report section. I can, for example, go to forward traffic, add a filter, choose to search by source, and add a value. The log view will then change to only include data that relates to your filter query. As with FortiView and Policy View, you can choose columns of information that you'd like to see. Should you want to revert back to the standard or predefined view, you can choose Reset Columns. You can also remove all filters if needs be. We will now take a look at some advanced interface options that are available on the FortiGate. Some of these options may change depending on the model and whether hardware switches are available within the specific model or not. This is a virtual machine, and therefore we will not have the opportunity to create hardware switches. However, we can create VLANs, interface aggregates, redundant interfaces, loopback interfaces, and software switches. I might for example, want to add a VLAN to my existing LAN interface as a trunk. I'll give the interface a name, add an alias. Let me add something else here. Choose the type VLAN as the interface type. Choose which interface this VLAN will be bound to. Enter the VLAN ID. Choose the role. Set an interface IP address. Choose the administrative access options, whether device detection is enabled or not, and select OK. Our VLAN has now been created under the physical LAN port 10 interface. We can add additional columns here, for example including the VLAN ID. In the same manner, other interface types can be created, including aggregates and software switches. As an example of a soft switch, I can create a new interface here using soft switch. I'll choose the interface members, choose the role, add an IP address for the interface, choose administrative access options, whether device detection is on. I'll include an option to scan connections to botnet sites and select OK. We now have a soft switch that can be used within our policies. Another example of an interface type we can use is a zone. A zone basically uses multiple interfaces as a destination or target. One thing to remember is that once interfaces have been added to a zone, they can no longer be targeted individually in policies or routing tables. I'm now going to create some policies that will use some of these new interface types. We'll go to Policy and Objects, Ipv4 Policies. I will create new. We'll choose an incoming interface of LAN, an outgoing interface of the VLAN. I'll give it a name. Choose our source and destinations, our services, whether to NAT or not in this case, as this is a private-to-private network link. I am not going to NAT. We can choose our logging settings and then accept OK. I'm going to add a new sequence grouping for this policy and some others. I'll call it LAN to LAN. Let's add an additional policy here for our zone. Add a new policy above this one, edit it, give it a name. We'll choose a new outgoing interface of our zone, source and destination. I'll choose for source our LAN address object. We won't NAT. We'll enable the policy and say OK. And so we can make use of the additional interface types and zones that we've created. The last section we're going to look at is link load balancing. We'll cover SD-WAN at a later stage. You will recall that we have two WAN interfaces. They are currently set to get their IP addressing via DHCP, and as such they have received the default DHCP routing distance of 5 on both of these interfaces. By default, the priority will be 0 for both, in which case these two interfaces have equal capability. Traffic will be load balanced equally across them by default based on the source IP. We can see some of this information in the routing monitor. Here we see our two WAN interfaces with a equal distance of 5. Distance is the highest value that will take precedence, followed by priority under normal circumstances. There are additional parameters such as metric and weight that can be used, but we're not going to look at that currently. Depending on the value of distance and priority, traffic will be carried over a link or not. If we have equal distance and equal priority, as in this case, then we have straightforward load balancing. If we have equal distance but a lower priority for one of the links, the link with the lower priority will take preference and traffic will only be sent over that link. If we have equal distance and a higher priority, that link essentially becomes a backup link. In the case where we have equal priority but different distances, then the link with the lower value distance will take priority. If we want to allow for failover of traffic, then we need to use the system link monitor to perform a health check and determine the status of a link and whether traffic needs to be failed over to another link. This is currently done from the CLI. I'll make use of my console to illustrate this. We'll log into our firewall. We'll go to the Configure System Link Monitor section, and by default this will be empty. We will create a new entry specifically for our WAN 1 link. Now we can set specific values to do the health check and then enforce a failover if the health check fails. The first thing we'll do is set a server that we want to use to monitor. This will be done over this specific link, so we'll set that in the source interface option. Let's see what options we have here. Okay, we need to use the real port's name. And we can also set a gateway IP if required. In this case we're using DHCP, therefore the gateway is provided automatically and we can't set it. Let's see our current configuration. The FortiGate will now check on 5 iterations with a 1 second differential whether the server is available over this particular port. If it fails these checks over the 5 iterations, it will then mark this interface as down and remove it from the routing table. This configuration option is the one that informs the routing table to remove this interface. We'll accept this change. We can now go to our network diagram and we can choose to disable this interface link for WAN 1. Yep, I don't want to delete my firewall. If we go back to our firewall now, we should see that that interface is down. And yes, we can see that the interface is no longer operational. If we go to our routing table monitor, we can now see that there's only one static route, and that is over WAN 2. If we were to generate traffic now, that traffic would be listed as being on WAN 2. Let's just generate some traffic. Okay, we now have some traffic. Let's go back to our firewall. We'll go to FortiView and check our traffic from an interface's point of view. I'm going to check traffic from the LAN source interface. This will be for our test workstation. And if we look at the destination interface, you'll notice that the traffic is now traveling over WAN 2. If we bring our interface back online, then the routing table should update accordingly again. Let's check our firewall. We'll go to Network Interfaces. Yes, you can see that our WAN interface is back online, and if we go to our routing table monitor, the route has been placed back into the routing table. You can make use of distances and priorities with multiple WAN links to put a hierarchy of failover in place. This concludes a slightly deeper dive into some options in policies, security profiles, networking and routing. I hope you've enjoyed it. Please like, subscribe and comment, and there will be more videos to come in future. Thank you for watching. Goodbye.